High-tensile steel and aluminum alloy tubes arrive at the factory and are unloaded for verification and storage. Inspectors measure tube thickness and verify material certificates to ensure mechanical strength meets required standards.
Strength confirmed?
Rubber, spokes, bearings, and coating materials are cataloged and stored under controlled conditions for traceability and future production use. The metal tubes are cleaned in chemical tanks to remove oil, dirt, and surface contamination before further processing. Steel tubes pass through a mild acid bath, then rinsed and dried to eliminate rust and prepare the surface for strong welding and coating. Each tube is scanned with a laser gauge to confirm wall thickness and dimensional accuracy. Annual measurements verify tube diameter and roundness to ensure proper frame geometry. Crack detection systems identify hidden defects, and any damaged tubes are removed from production immediately. CNC machines cut the metal tubes into exact frame lengths with high precision. The tubes are bent and end-shaped to match the bicycle's geometry before welding begins.
Angle at 45 degrees. Hold it.
The prepared tubes are fixed inside a welding jig to maintain perfect frame alignment before joining. TIG welding melts the aluminum at high temperature, permanently joining the tubes into a strong frame structure. After welding, the individual tubes become a rigid triangular frame, forming the backbone of the bicycle. The welded aluminum frames are heated in a furnace to restore strength lost during welding. The frames are rapidly cooled in water, then aged at controlled temperature to achieve full structural hardness. Natural and synthetic rubber are blended with carbon black inside an industrial mixer to form the tire base compound. The mixed rubber is processed into uniform sheets, ensuring consistent material quality before shaping. The rubber compound is extruded through a die to form the tire tread with controlled thickness and width. The layered rubber and steel bead are pressed into a circular mold to create the final tire structure before curing. Inside the heated press, the tire is vulcanized at high temperature and pressure, strengthening the rubber through sulfur cross-linking. The hot tires are gradually cooled to stabilize their structure and prevent surface cracking. The heat-treated frames are air-cooled to relieve internal stress and maintain structural integrity. The frame is sandblasted to remove oxidation and create a rough surface for better coating adhesion. Electrostatic spray guns apply powder coating evenly, ensuring full surface coverage and corrosion protection. The coated frames are baked in a curing oven, melting the powder into a durable and smooth protective layer. Robotic arms transfer finished frames between stations to ensure precise positioning and reduce manual handling errors. Automated conveyor systems transport frames smoothly across production areas, increasing speed and maintaining workflow consistency. Laser alignment systems check frame geometry to ensure precise angles and structural accuracy. Coating thickness is measured to verify proper protection and consistent finish quality. Core drivetrain components are installed and tightened to exact torque specifications for safe power transfer. The wheels and braking system are fitted carefully to ensure proper alignment and smooth rotation. Final components are installed, transforming the painted frame into a complete and functional bicycle. The assembled bicycle is tested on rollers to check wheel alignment and smooth gear operation. A final visual inspection confirms surface quality, proper assembly, and overall product appearance. The final product is strong, lightweight, corrosion-resistant, and ready for years of reliable performance on the road.